This video is for class 9 physics, and in this video we are discussing about the comparison of speed of sound with the speed of light. So there are the following 4 points of distinction between the propagation of sound and propagation of light waves, right? Because both are energy. Number 1, light waves can travel in vacuum, but the sound waves cannot travel in vacuum because sound needs material medium to travel. Point number 2, the speed of light waves is 3 multiplied by 10 to the power 8 meter per second in air, which is about a million times greater than the speed of sound in air, which is 330 meter per second at 0 degrees Celsius. Now, number 3, the speed of light waves decreases in an optically denser medium, which means for example, the light is traveling in glass, so the speed will not be 3 into 10 to the power 8. Okay, it will be slightly less. So the speed of light in water, which is slightly denser than air, is 2.25 into 10 to the power 8 meter per second. In glass is 2 multiplied by 10 to the power 8 meter per second, while the speed of sound waves is more in solids, less in liquids, and still less in gases, because it depends upon the elasticity of the medium. Speed of sound in steel is nearly 5100 meter per second. In water it is nearly 1450 meter per second, and in air is nearly 330 meter per second. But the light cannot travel inside the steel because it is opaque, right? It can travel only in the transparent and translucent substances. Now 4, the light waves are transverse electromagnetic waves. They are transverse, okay, they are transverse waves, and they are electromagnetic waves, whereas the sound waves in air are longitudinal mechanical waves. The other word for mechanical we can use elastic, okay, elastic waves, because they require material medium to travel, and the medium must be elastic in nature. By this time you know this factor, okay, that elasticity, right? Know this factor plays a very vital role in the speed of sound. Now the consequences of the large difference in the speed of sound and that of light. Thunder and lightning. In thunder, uh, lightning is seen much earlier than the sound of thunder is heard, although they are produced simultaneously. The reason is that light takes almost negligible time in comparison to the sound, because it's million times much faster, right, to the sound in reaching us from the place of thunder, because the speed of light is much more than the speed of sound. Therefore we see lightning, and then after some time we can hear the thunder. Number 2, when the starter in an athlete event fires a gun, the spectator sitting at a distance hears the sound of the fire a little later, while the smoke is instantaneously seen. The reason is that the speed of light is much more compared to the speed of sound. Number 3, the spectators watching the cricket game hear the sound of a stroke a little later than the batsman is seen actually making it, right? So this is also again because the light travels faster than sound. So these are a few examples where you can see the light travels faster than sound. Now coming to the last part of the video, which is the experimental determination of the speed of sound, right? The experimental determination of the speed of sound. The fact that light travels in air about a million times faster, right, a million times faster than the sound, can be used to determine the speed of sound in air. Now the experiment: choose two places A and B at high altitudes facing each other at a known distance d apart, say 1 kilometer, in a still air. The air should not move, otherwise we have to counteract the direction of the wind as well. The distance d is noted, which is about 1 kilometer. At each place there is an observer with a gun and a stopwatch. So basically we are having two buildings, right? Okay, let me go back to the blank space where we can draw. So here we are taking two buildings, right? Okay, we shall take two buildings. So this is building A, right, and this is the building B, right, and then we have two observers on the building, suppose, and the distance between these two building is D, right, which is nearly 1 kilometer. Then we can have observers as well, right. So the first observer here, right, with the stopwatch and with the gun, right, the stopwatch and the gun, and we have a second observer here again with the stopwatch and with a gun probably, right. So I hope you are understanding the situation, right. Okay, so let us go back to the book, then again we will come back to the drawing. So at each place there is an observer with a gun and a stopwatch. First the observer at place A fires the gun, while the observer at place B starts his stopwatch immediately on seeing the flash of the fire at A and stops it when he hears the sound of the fire. So the observer at B by his watch thus finds the time interval T1 taken by the sound to travel from A to B. Now the observer at the place B fires the gun. The observer A does the same thing what B had done. He starts his stopwatch when he sees the flash of fire at B and stops it when the sound comes to him, right. Thus the observer A by his watch finds the time interval T2 taken by the sound to travel from B to A. The average of the two time intervals T is taken. This is the time taken by the sound to travel the distance D between the places A and B. The speed of sound is then calculated by using the formula V equals to distance by time. Here the average time is taken to counteract the direction of the wind, right, from both the sides, okay, from both the sides. So let us go to the picture, right, and then try to understand. So we are back to our image, okay. Let this be observer A and this be observer B. So when the observer A fires the gun, right, he starts the watch. Then after some time when the sound of the gun reaches the observer B, he stops it. Let the time be T1, and then now it's observer B's turn to fire the gun. Now he fires the gun, right. Now he starts the watch and the sound slowly reaches to the observer A, right, and he notes down and stops the stopwatch and notes the time it to be T2, right, and the average time will be T1 plus T2 divided by 2. So this will give us the average value of the time. Now after knowing the average value of the time, they can use the formula for the speed, which is V equals to distance by time. V equals to distance by time. So now the distance is known. We can always measure the distance, right. Suppose the distance is 1 kilometer, we can put the values, right, and then when we divide it by the time, which is the average time of T1 and T2, we shall get the speed of the sound. Okay, I hope you have understood the experimental determination of the speed of the sound. Now going back to our book, so note, in this experiment we measure the time interval 2 times, first for the sound to travel from A to B and then from B to A, so as to eliminate the error arising due to the flow of the wind. However, the speed of sound so determined is not still very accurate because of the personal errors of the two observers and the variations in the temperature and the humidity in the air between the places A and B. So I hope the videos are okay, you are understanding it, okay. Thank you so much, this much for this particular video. See you in the next video.